So with piecewise functions, I think sometimes a lot of people get confused when they mix functions like this. But I think the most important thing you need to know is that these are two functions. Okay, so these are two functions, and so you have this function working with this domain, and then you have that function working with that domain. So don't confuse it where you want to use both domains on the same equation. So they're just saying that this is valid for these numbers, okay? And this applies only to that domain. So if we understand that, then we should be able to graph it correctly. So remember, we looked at x squared. Here there's x squared, which is quadratic, and here is what? There we have a linear function. So we have a line and then we have a quadratic. Now this is easy, an easy example, because this is x squared. So always try to draw these as perhaps dotted lines, right, at first. So I will say x squared. I know the parent function is like this. Remember we discussed parent function in our previous discussion. So this is x squared, right? So I will indicate that this is x squared, right? Now they've been very strict and they've given me a domain. They're saying that this at less than or equal to 1, so if our 1 is here, I'm going to have this graph. So it means that I'll have this because I don't include, I'm putting a bigger circle than normal because I don't need to include this. I need to include this value. Okay, I need to include because it's less or equal to, so this is included. This is going to be my function along that dotted line, not separate, okay? Then I look at this other domain. They're saying that if it's greater than 1, meaning that I'll have a circle. So maybe, for example, if this is going to go through here, I'll make a circle like that. Then if my equation is from here, like this, for example, okay, like that, then I can have it dotted like that up to there, right? Then I know that my equation begins from here and goes the other way, right? From there to the other side. So the lines that I've put in bold are the ones that now are part of the equation. So this is fx is equal to 2x plus 1. Okay. And then this is y is equal to x squared. So this is my piecewise function. This part here and that part there. Okay. So this is piecewise functions. You can have 3 functions. You should be able to simply do that. Or you can have 4 functions to be able to do this. Okay. All right. Do another example. So this other example, what we're looking at now is similar to the previous example, except that now will be a little bit more detailed than the previous example. So here you see we already concluded that these are applying to each of these. Okay, 2 functions, 2 different requirements, right? Then we want to make one function of one graph. Okay, so this has become one graph. Let's just put let's just get these preset lines so that it looks neater. All right. Okay, so now let's go. So we are saying that we've got this Cartesian plane, and with this we're going to say that this is y axis and then that's x axis. Always label these Now, what are we saying here? We're saying that we've got this function here, which is y is equal to 2x plus 8. Now, look at this. Here, it's actually easier to start with this. Okay, why? Because this is a parent function. Remember, we looked at parent functions and we said that this is x squared. So if I've been asked to sketch, all I need to do is to show my vertex. Okay, I need to be careful that my vertex is correct. First of all, I need to look at this equation or function. What does it show me? It's a positive thing, so it will have a minimum, which is here. The vertex will be like this. So this function will be will have a minimum, not a maximum. Maximum, it will be like that, right? So now we know that we have this function, and then we look at the range. What is the range saying here? Sorry, the domain. Okay, range, we'll look at it a little bit later. This is the domain. So what is the domain? The domain shows us that x must be greater than -2. So we know that x minus 2 will be somewhere around here. And they are saying that this is supposed to be greater, meaning that we are not including this point at this, when we are doing this function, we're not including that point, right? So we have our function here, and we're saying that they didn't give us a limit here. They just said it's going to be greater. So we can show with this sign that this actually goes on forever, right? Then we look at this second function here, right? Look at this second function. It's saying that we are actually going to have this function, which is y is equal to 2x plus 8. Now here we're going to say y, we're going to create our coordinates. So our coordinates are going to be, the easiest is 0. If I put 0 here, I get 8. What's the other easiest coordinate I can get here? It's when maybe I put a 1 as x. So that's 2 times 1 plus 8. So I get a 10, right? So now I come and plot these because it's a line, it's easier. So I come to 0,8. 0 will be here, and then maybe my 8 will be somewhere here, okay? And I get my 1, I get my 10, my 1 and 10, maybe 1 is here, 2 was there, 1 will be somewhere here maybe. So 1,10 will be somewhere here, right? So that is my line. Now I connect these 2 points. So I'll connect with a dotted line, just like this. Okay, just like that. Now you see that I've targeted this point for some reason. Why? It's because these have used the same point. So I know in my from experience that this actually needs to pass there, because this is a point that's limiting both of the functions. Now what are they saying in terms of the limit? They're saying that it should be less and equal to. So we check what this means. Remember, we said that if it includes, we need to, now this point has been included. Okay, so it's going to be a solid point. Now they've said that it has to be less, meaning that less is this way. So we're not going to complete this function this side. We're just going to come this side and complete this side. Okay, let me do it better. So we're going to continue this function this way. So our final function is actually just this. It comes here, obviously on, maybe on with pen and paper. You can do a better job than this. All right. So it's going to be, that's going to be our function. These are just dotted. Those are just dotted. They're not part of this function. This function is just what we've worked out now, which is going to be this portion here, right? That's our piecewise function. Thank you for following, and all the best. And remember, you can actually have, maybe this is your Cartesian plane, okay? And then maybe you do one function here. It could be like a line there. It could be a portion of this here, and it could be maybe another line there. It's not always that they have to have that connection. All right. All the best and keep watching.